everyone, Mrs. Vara here, and this is the first lesson for Unit 4, and it's kind of an introduction lesson because it is review, stuff you've had in Algebra 1. So what we're doing here is you can identify the base and an exponent. So remember, this is what this looks like. Big number or variable on the bottom is the base. Little number is the exponent. And I can simplify the product. So remember, product means multiply. That's why I put this little multiplication symbol there, of monomials. So let's just do a little review here of, let's see if I can get this camera a little better. There we go. A monomial means you have one term. So a binomial means you have two terms. And remember, terms are separated by a plus or a minus. So this would be a binomial. Three terms, 1, 2, 3, would be a trinomial. All of these are called polynomials. And then anything bigger than a trinomial we just refer to as a polynomial. Okay? So that's just a little review. I would pause the video and add this to your notes because it is important. Okay, so the first thing we're going to talk about is a power, or we often refer to it as an exponent. So, right, this is what it looks like. Something to a power. So, what is the base? You'll want to add this to your notes. The base is b. And the way I like to remember it is it's bigger than the exponent, right? The base is big. And the exponent in our example is n. So the exponent is the small number. I think you know all this pretty well. And then all this is a shortcut for repeated multiplication, right? So if I want to multiply 2 by itself 4 times, I could do that. Or I could just write 2 to the 4th. Easier, shorter. I was trying to think of a non-example of a power, and I was thinking, well, I couldn't use a whole number because a whole number has a power. It has a power of 1. So I thought a non-repeating decimal would not have a power. So that would be a non-example. All right, now let's get to our exponent rules. This looks a little blurry. Okay, so I can simplify product of powers. So remember, powers are exponents. Product means to multiply. So this is the rule. If I'm multiplying common bases that have exponents, I keep the base, add the exponents. So the important characteristics here are, let me rewrite this, add exponents. Okay, and then what you might want to, I'm getting a different pen here. What you might want to do is remind yourself, okay, don't like that pen either. Go back to my blue one. Remind yourself that you must, I'm going to make that must have common bases. Okay, so this only works when your bases are common. Here's an example. X to the second times x to the third. Common bases. My bases are both x's, so this would equal x to the 2 plus 3, which would be x to the 5th. Keep the base, add the exponents. A little trick here is multiplying makes things bigger, so I want to add the exponents to make it bigger. Non-examples would be this. If I'm adding bases with exponents, I don't use this rule, okay? And here, I would not use this rule. I would not call this x, y, I don't know, what would you do to the 9th? That is not true because the bases are not common. Okay, now we're going to look at some examples on the next page of your notes. Okay, so common bases, keep the base, add the exponents. This would be 4 to the 7th. I don't know about you, but I don't know what 4 to the 7th is. 4 to the 7th is 16,384. Whew. I would say we're just going to keep that at 4 to the 7th. Okay, this is multiplying, so think of multiplying your coefficients. You'd have 6 times 1, so that would be 6. Keep the base, add the exponents. 2 plus 4 is my exponents. So this would simplify to 6x to the 6th. Multiplying two monomials. Multiply your coefficients, negative 12. Multiply your common bases, x to the 4 plus 2. And the y, don't leave it behind. Keep it there. It's part of your problem. I don't have another y to multiply it by. So my final simplified answer would look like that. Negative 12, x to the 6, y. These are your turns. Okay? Pause the video, try them, and then come back for the answers. Okay, so here are your solutions. These are pretty straightforward. The only thing I would say is this v has an invisible exponent of a 1, so you might want to add that invisible 1 there, so you remember this would be v to the 5th. Same thing here with the a. This becomes a to the 3rd because 1 plus 2 is 3. Okay, now what do we have? Product of powers. No. This is wrong. Cross that out. Power of powers. That's what we're doing here. And here is our rule. I have a base, raised to an exponent, and then raised to another exponent. So that's the power of the power. And when you're doing that, you multiply the exponents. So my little tip for this is exponents make things big really fast. So I don't want to just add the exponents here. When I have a power to a power, it's getting big really fast, so I want to multiply the exponents. So this is what we're doing. This looks so blurry, I don't know why. Let's see, I think maybe it's the glare from my light. There we go. So important characteristics, multiply the exponents. Little tip to help you remember you multiply. Power to a power gets big fast. Pause the video, fill that in. Here's your example, x to the 3rd power, then the whole thing raised to another power. So power to a power I multiply, that's x to the 12th. Could not think of a non-example, so we won't do a non-example. Okay, here's some examples. Power to a power, multiply, this becomes x to the 10th. 2 times 5 is 10. Power to a power, multiply, 7 times 3, 21. Power to a power. Now here's what you want to think about here. We have parentheses, right, with the power outside. So it's, think almost like distributive property. I want to share that 2 on the outside with everything in the parentheses. So that's what I get. So this becomes 9x squared y squared. Okay, these are your turns. So pause the video and then come back and check your answers. Okay, there's your answers. Hopefully you got those correct. Okay, let's keep going. I get through one more rule and then I'll go to a second video because this one's getting long. So this is good. These are kind of a combination. We're multiplying and we have power to a power. So always, remember order of operations says take care of your exponents first. So we want to take care of these exponents first. Remember, the 3 outside means I'm going to put that 3 exponent on 10. So I have 10 to the third, a to the third, and here, power to a power, b to the 12th. All of that times 3 to the second, b to the second, then raised to the second again, b to the fourth. Okay, what the heck is 10 to the third? This is what's so fun about 10 to the third. This 3 means I'm going to have 3 zeros. So it's 1,000, a to the third, b to the 12th, times 9, b to the fourth. Well, let's put that back in parentheses. Okay, so now I'm multiplying. So I want to add the exponents where I have common bases. Well, first let's multiply our coefficients. So that would be 9,000. I only have one a, so we're just going to do a copy job on a to the third. But down here we have b to the 12th times b to the fourth. So common base, keep the base, add the exponents. That's b to the 16th. So that's the fully simplified form of that. How do I know that I'm fully simplified? I only have one a and one b. So if, for example, in this step, how there's 2 b's, I'm not fully simplified. My variables should only occur once. Okay, so pause the video, try this, and then come back and check your answers. Okay, hopefully you got that. You also could kind of see me working it out so you can see where my steps came from. Okay, I'm going to stop this video now and I'm going to finish the notes in another video.